So we're thinking here about the rules of divisibility. So to be divisible means that you can evenly divide a number, right? So if you have a number that you want to test if it's divisible. So let's say we have the number 14. Actually, we'll just do the number 15. Okay, so if we have the number 15 and we want to decide if it's divisible by certain numbers, we can ask ourselves these sort of questions to determine if it is divisible or if it is not divisible evenly, meaning it can be divided with no remainders by this number. So a number is divisible by the number 2. Come on. By the number 2, if the number is even. So is 15 even? Does it end in a even number, 0, 2, 4, 6, 8? And so, no, it doesn't. So it is not, 15 is not divisible by 2. Okay, what about 3? A number is divisible by 3 if you add the digits, and you'll see if the number is divisible by 3. So if we add up our digits, meaning we add 1 plus 5, we get 6. Well, is 6 divisible by 3? 3, 6. Yeah, it is. So also 15 is divisible by 3. So 15 is divisible by 3. What about the number 5? If it ends in 5 or 0, then you know that 5 is your hero, meaning it's divisible. So does it end in a 5 or a 0? Well, yeah, it does. It ends in a 5. So 15 is divisible by 5. What about 6? If it is divisible by both 2 and 3, 2 and 3, then you get 6 for free. So that means if it's an even number that's also divisible by 3, meaning you add the digits, and though that is divisible by 3, then you get 6 for free. So if it's divisible by both 2 and 3, it's also divisible by 6. In this case, it is divisible by 3, but not 2. So 15 is not divisible by 6. What about the number 9? So similarly to our 3 rule, you'll add the digits. Yeah, that's fine. Just test the divisibility of 9. So if it's divisible by 9, then so is that number. So when we add the digits, 1 plus 5, we got 6. Well, is 6 divisible by 9? No. So 15 is not divisible by 9. What about the number 10? If it ends with a 0, then it is divisible by 10. Well, does 15 end with a 0? No. So it is not divisible by 10. So what we have here is we have another sort of sheet. You have this in your slides. I've just zoomed it in so it's a little easier to read. And it has those same 2 and 3 and 5 and 6 and 9 and 10 like you've been familiar with. It also gets into some more divisibility rules as well. So we have a divisibility rule for 4, whereas if the last 2 digits of a number are divisible by 4, then the whole number is divisible by 4. So if you have the number 2,216, you say, I have no idea, but I do know that the last 2 digits are 16, and I know that 16, 4 is divisible by 6. 16 is divisible by 4. If I count by 4s, I will hit 16. So you can also think about 7s. That's a tricky one. So, and it's a little bit less used, but the idea is that if you have a number, like we'll just take the number 14 for now to keep it a little simple. So if you double the last digit, so our last digit is 4 here. If we double that and we get 8, 8, and then you subtract it from the rest of the numbers, and the answer is either 0 or divisible by 7. So if you take 8 minus 1, you get 7. So that means that 14 is divisible by 7. And the last one I'm going to get into here, you can kind of explore 8 and 11 on your own, is this idea of 12. So you know a number is divisible by 12 if it's divisible by both 3 and 4. So it can be helpful to know that 4 rule, as well as the 3s. Add the digits and you'll see if it's divisible by 3 and 4, meaning are the last 2 digits divisible by 4. And if it's true of both, then that number is also divisible by 12.